Alright, so now let's do a small exercise to understand this better. So here I have already previously written code. Let's reuse this code, no problem. So here in the main, what I do is I call a generate interrupt function. Okay, now let's keep a breakpoint here and let's go to debug mode and let's hit run. Okay, so now the program is actually halted here, right? So that means the processor is now about to execute this instruction BL, that is branch with link to this address, right? So this function is actually located at this address. Okay, so that also means that this address is now going to be placed into the PC, right? Now if I hit single step here, this address will going to be placed in the PC. According to our discussion, what I just said is any address you place in PC must has its 0th bit as 1. Okay, so but look at this address. The 0th bit of this address is not 1, right? So but I just said that this is going to be placed into the PC, right? So that is actually true. If I just single step, okay, you can see that that address is actually, this address is actually placed in PC. Okay, so now here you are expecting that 08000339 should be placed into the program counter, isn't it? But for PC, the 0th bit is not useful. The 0th bit is actually copied to the T bit of the EPSR. So that's why your IDE shows it as 338, but truly speaking 339 is actually placed into PC. Okay, now what we'll do is, instead of calling this function in this fashion, okay, so what I do is I'll just create one function pointer, jump addr void, and I initialize this function pointer to the address of this function. So I just write like this. Okay, so here I just created one function pointer called jump address, and I initialized that jump address function pointer to the address of this function, and then I call jump addr. I just dereference that pointer so that I come here. Now these are legal lines of code, isn't it? So I'll just compile it, and yes, it compiled successfully. And now I'll just keep a breakpoint here, and I'll just flash this code, and I'll just go into the debug mode, and I'll just hit run. And now I am about to dereference this pointer, but look at jump address value. The compiler is stored the value 0x8000339 in the jump addr pointer, right? But what is the address of generate interrupt? The address of the generate interrupt is 338. So that means the compiler somehow managed to increment the 0th bit to 1. So what this line does, here it is, blx branch, right? Now I'll just single step it, okay, and observe PC here, and PC is loaded with 338. So that's correct, okay, and the T bit is 1. Okay, so now your control comes to generate interrupt. That's fine. So now what I do is, instead of making this, what I do is I'll just write 0x0800, okay, 0338, and I will just make it as void pointer here. Here I actually hard coded the address of this function into this pointer. So now we'll see how this works. Okay, great. So now let's compile this code and let's download, and I'll just keep a breakpoint here, and let's go into the debug mode, and I'll just hit run. Okay, great. So now I am about to dereference this pointer, and this pointer, the dereferencing this pointer is nothing but placing, okay, this address onto the PC, isn't it? So because this line is nothing but this one, BLX R4, okay, the content of R4 is this address 338, which is going to be placed onto the PC, right? And observe that the value of the 0th bit is not 1, okay, it is 0. So now let's remove this breakpoint and just do single step, okay. So before that, okay, let me check what exactly is the value of t-bit. T-bit is 1, okay, great. And now observe PC and t-bit when I do the single step. Now I'm doing the single step, okay, here it is. The PC is loaded with 338, that's correct, this address, and the t-bit is cleared, okay. So why? Because the 0th bit is not 1, right? So that's why the 0th bit is 0, that's copied into t-bit, okay. Now the processor is about to execute this instruction, okay, which is there at 338 address. But according to our discussion here, if t-bit is reset, then processor thinks that the next instruction which it about to execute is from ARM instruction set. So this must be ARM instruction set instruction, but the Cortex-M processor doesn't support any ARM instruction set. This is actually thumb instruction set. So that's why the moment you try to execute this instruction, the usage fault exception will trigger and you'll be trapped in that exception handler. So let's see that happens or not. So I'll just hit single step here, and here it is, we are trapped in the hard fault handler. Since usage fault handler is not yet enabled, we actually trapped in the hard fault handler. So that clearly indicates that, okay, you should not execute any instruction in Cortex-M processor by keeping t-bit as 0, okay. The t-bit has to be 1. So how to solve this problem now? So now just increment this address by 1, right? So now you have made this address as odd, isn't it? Okay, the last bit is maintained as 1, and that address will be dereferenced here, and when that address is copied into the program counter, the last bit will be copied to the t-bit, which is 1. So your thumb state execution will be maintained, okay, and the processor will be happy, right? So now let's check this, okay. So now let me just build this code, let me download, and okay, so now let me just keep a breakpoint here. Great. So now you are all set to place this address, right, that is 339, okay, onto the PC, right? So just expand the PSR, okay, the t-bit is 1 and PC is this value. So now I'll just remove this and I'll just do a single step, and you can see that we indeed reached the generate interrupt function, okay, which is there at this location. If you don't increment this address here, you saw that the control actually went to hard fault handler, right? So that's the importance of the t-bit. So most of the time you need not to worry at all, okay. You should worry only when you hard code the value of the function address into some function pointers. In this case, I'm hard coding the address of this function, okay, into this pointer. In that case only I should manually take care of maintaining the 0th bit as 1. Otherwise, if I just do something like this, then I need not to worry at all, because the compiler will take care about incrementing the 0th bit. Great, that's all I want to talk about the t-bit of the EPSR register, and let me know if you have any questions, and I will see you in the next lecture.